సబ్స్క్రైబ్ చేయండి. ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయండి.
Now we are going to discuss Wien's law of black body radiation. What is the Wien's law? Is the product of wavelength corresponding to maximum energy. Wavelength corresponding maximum energy is the delta suffix lambda suffix m, and the absolute temperature is constant. This is the Wien's law. The product of wavelength corresponding to maximum energy. Wavelength corresponding maximum energy and absolute temperature is constant. This is the Wien's displacement law or Wien's law. And also same this is the one way. Another way, the wavelength corresponding to maximum energy, is inversely proportional to absolute temperature. So this equation can be written as wavelength corresponding to maximum energy is equals to constant into 1 upon T. Then cross multiplication, wavelength corresponding to maximum energy into T is constant. So this is the one way of the displacement law, Wien's. This is the other hand Wien's displacement law. So one is the product of wavelength of corresponding maximum energy and absolute temperature is constant, and another is wavelength corresponding to maximum energy is inversely proportional to absolute temperature. This is the Wien's displacement law. Now we have to derive the Wien's displacement law. That Wien's displacement law is the wavelength corresponding to maximum energy into temperature is constant. Now we have to derive this equation. Let us consider a spherical enclosure. This spherical enclosure with perfectly reflecting walls and capable of expansion radially outwards like a football. The perfectly expansion అవుతూ రేడియేట్ అయ్యే వాల్స్తో ఈ స్పిరికల్ ఎన్క్లోజర్ అనేది ఉంది. రేడియస్ ఆఫ్ ద స్పియర్ ఈజ్ ద ఆర్. Let the sphere is filled with black body radiation of energy density U. This sphere filled with black body radiation of energy density is small u at temperature T. Then volume of the sphere is the V. So then the total internal energy U is equals to the total volume into energy density. Let us imagine the expansion of enclosure. Here the expansion of sphere enclosure is in the adiabatic process. Then the heat energy is constant. Here the heat energy is constant. That means Q is constant. Then dq, the derivation of Q is 0. Derivation of constant is 0. According to thermodynamics first law, dq equals to du plus dw. Then dq equals to du. dw means pdv, because work done equals to force into displacement. Then force equals to pressure into area into displacement, that is the pressure into dV. So then dq is 0 because the process in spherical enclosure, that is the adiabatic process. In the adiabatic process, thermal energy is constant. Then thermal energy is constant, the derivation of constant is 0. So according to thermodynamics, first law, dq equals to du plus dw, then dq equals to du plus pdv, then dq is 0 equals to du plus pdv. Then the internal energy is vu. Then this equation can be written as d of vu. In the place of u, we substitute the vu plus pdv is equals to 0. Then the derivation of the uv method, v du plus u dv plus pdv is equals to 0. By electromagnetic theory of radiation, the pressure P is equals to 1/3 energy density. 1/3 energy density. This is the, according to electromagnetic theory, the radiation exerts a pressure P is equals to 1/3 energy density. 1/3 energy density. Then P equals to 1/3 U. 1/3 U. In the place of P, we substitute this equation. We substitute that equation. Then V du plus U dV. In the place of P, 1/3 U dV is equals to 0. Here 1 U dV, 1/3 U dV, V du plus, this is the 4/3 U dV is equals to 0. 1 U dV, 1/3 U dV is equals to 4/3. Here 3 is the LCM. 3 into U dV, 3 dV plus 1 U dV, 4 U dV. So U dV plus 4/3 U dV is equals to 0. This equation divided by UV, UV on both sides, then this equation can be written as U du plus UV plus 4/3 U dV upon UV plus 0/UV. So this equation can be written as, then here V is cancelled, here U is cancelled. Remaining is du upon U plus 4/3 dV upon V is 0. Integrating on both sides, then integration du upon U plus integration 4/3 dV upon V is equals to 0. Then integrating on both sides, then integration 1/U du plus 4/3 integration 1/V dV is equals to 0. So this equation can be written as log U, integration of 1/U log U, 4/3, this is the log V. So 0. The derivation of constant is 0. Integration of 0 is constant. So here log constant, log of constant. Then this equation can be written as log of u into v upon v power 4 upon 3. So then in the simplify log u, this equation can be written as log v to the power of 4 upon 3. This equals to log constant. Then log m, log n, so mn. So log u v power 4 upon 3 is equals to log constant. Log constant. This equation can be written as u v to the power of 4 upon 3 is constant. Log is cancelled. Then finally u into v to the power of 4 upon 3 is constant. But Stefan's law of radiation is total energy is directly proportional to fourth power of temperature. So E equals to sigma T to the power of 4. Here sigma is the Stefan constant. This is the energy. So here this is the energy density. So this is also can be written as U sigma T to the power of 4. This is the energy density. This equation also can be written as this. So in the place of U we substitute this equation. U means sigma T to the power of 4 V to the power of 4 upon 3 is constant. So here sigma is also constant, this is also constant. Sigma can be written as constant upon sigma is also constant. T to the power of 4 V to the power of 4 upon 3 is constant upon sigma. This is also constant, this is also constant. Totally this equation can be written as T to the power of 4 V to the power of 4 upon 3 is constant. So this equation can be written as in the power of 4 upon 3. This equation can be written as T V to the power of 1 upon 3 is constant. T to the power of 4 V to the power of 4 upon 3 is equals to constant. Then we eliminate the 4, then T power 1 V to the power of 1 upon 3. 4 is the eliminate. T V to the power of 1 upon 3 is constant. So here V is the volume of the sphere. What is the formula of the volume? Volume is equals to 4 upon 3 pi r cube. In the place of this equation V, we substitute this equation. Then T is the 4 upon 3 pi r cube to the power of 1 upon 3 is constant. Then this equation can be written as T 4 upon 3 pi to the power of 1 upon 3. Here r cube 1 upon 3 is constant. Then this equation can be written as 3 is the cancel. T 4 upon 3 pi 1 to the power of 3 is equals to constant. Then this is the final equation. Here T into 4 upon 3 pi 1 to the power of 3 r 3 1 by 3 is cancelled, r is constant. This is the final equation in this session. Next of all, the radiation field in the enclosure will undergo continuous due to here from Doppler effect. Now the radiation field in the enclosure, this is the enclosure, let us consider this is the enclosure. Due to Doppler effect, the wavelength will be changed. The wavelength will be changed. So this diagram is imagined in this sphere. This is the S1, this is the S2, this is the S1, this is the S2. First of all, the radiation is incident on this wall, then it's reflected, then this refracted, in the way refracted, in the way reflected or refraction, transmitted. Then this ray reflected backwards. So we imagine this diagram in this sphere, then clearly we observe OA is the ray of radiation, is incident at wall S1. The wavelength of OA ray is the lambda, this is also lambda, this is also lambda. After incidence, OA ray is reflected along AC, is reflected along AC in this way. Okay, along AC the wavelength of radiation is also lambda. So here AC is lambda, AC is lambda. After some time the radiation produced heat energy, then the wall displaced S1 to S2, then the wall displaced S1 to S2. In this case the ray OA reaches B at wall S2, then this ray is reflected along BD. This ray is reflected along BD in this way. So this is also reflected ray, this is also reflected ray. So then the wavelength of BD is also lambda dash or lambda 1. So this is the lambda 1 or lambda dash, this is also lambda 1 or lambda dash or lambda 1. So now we calculate the change in wavelength, that is the d lambda equals to lambda dash minus lambda dash minus lambda. Here lambda dash is the AD minus, this is the AD minus lambda is the AC. Then AD is calculated by AB and BN and ND. So this distance is equals to first of all A to D, A to B, B to N and N to D. So that means AD is equals to A to B plus B to N and N to D. So A to D. So AD means A to B plus B to N plus N to D minus AC. Here ND is equals to so this is the normal, this is the ND, this is the AC, this is the AC, this is the ND. So this side is equals to this side. So ND is equals to AC. So this value is substituted in this equation. So d lambda is equals to AB plus BN plus AC minus AC. Here AC is cancelled. Remaining is the d lambda equals to AB plus BN. AB plus BN. So that means AB plus BN. So this is equals to AB is equals to A dash B. AB is equals to A dash B. So this equation can be written as d lambda equals to AB plus BN. AB is equals to A dash B. So in the place of AB we substitute A dash B plus BN. A dash B plus BN. A dash B plus BN. So that means A dash N. D lambda equals to A dash N. This is the total. A dash N is the, this is the change in wavelength. From right angle triangle, this is the right angle triangle. From right angle triangle A dash N. This is the right angle triangle. This is the right angle triangle. This is the theta. So this is the A dash N. A dash N is the adjacent side of theta. So then now we calculate the cos theta. Cos theta equals to adjacent side upon hypotenuse. So cos theta equals to adjacent side is the A dash N upon hypotenuse A dash. Cos theta equals to A dash N upon A dash equals to AM plus M A dash. Now we observe AM equals to MA dash. So in the place of AM we substitute the MA dash. In the place of MA dash we substitute the M. So this equation can be written as cos theta equals to A dash N upon 2 AM. So then A dash N equals to cos theta into 2 AM. So here A dash N equals to d lambda cos theta 2. AM is the, this is the distance. So then distance is equals to, velocity into time. So velocity equals to distance upon time, then distance equals to velocity into time. So this distance is equals to velocity into time. So AM is equals to Vt. So d lambda equals to cos theta into 2 Vt. This equation can be written as d lambda equals to 2 Vt cos theta. This is the change in wavelength. So but time is equals to, so that means generally velocity equals to distance upon time, then time equals to distance upon velocity, distance upon velocity. Here time equals to, distance means here wavelength of radiation, velocity means velocity of radiation, that is the c. So then time equals to wavelength upon c, then wavelength equals to time into c, time into c. So then this equation can be written as, d lambda equals to 2v. This is the time. In the place of time we substitute wavelength of c, wavelength, and c cos theta is the cos theta. This is the change in wavelength. So velocity equals to distance upon time, time is equals to distance upon velocity. Here time is the time, distance is the wavelength, velocity is the wavelength of radiation. So this equation is substituted in the place of t, d lambda equals to 2v. In the place of t we substitute wavelength lambda upon c, here cos theta. This is the change in wavelength, this is the change in wavelength. So here the radiation is a repeated reflection in spherical enclosure. So in this type the radiation is repeated reflections in spherical enclosure. Now you observe two successive reflections. In spherical enclosure. So the spherical enclosure, this is the spherical enclosure, this is the spherical enclosure, this is the radiation, this is the radius, this is the radius. So the reflections, this is the theta, this is also theta, this is the r, this is the r, a, b. So we observe this diagram, the radiation is repeated reflections in spherical enclosure. The wave travels a distance 2r cos theta, 2r cos theta. That means the wave travels 1 hour. So the wave travels a distance in spherical enclosure is the 2r cos theta. So the number of reflections in 1 second defined by the ratio of velocity, the radiation to wave travels distance. The number of reflections in 1 second, so the number of reflections in 1 second, that is the number of reflections in 1 second is c upon 2r cos theta, So now the number of reflections in time dt is c dt upon 2r cos theta. So here the number of reflections in 1 second, this is the number of reflections in dt. So c into dt upon 2r cos theta. So now we have to calculate the change in wavelength in time. The change in wavelength in time dt is given by change in wavelength into number of reflections in time dt. What is the change in wavelength? Change in wavelength is the 2v lambda upon c cos theta. Number of reflections in dt, it is the c dt upon 2r cos theta. Now here d lambda is equals to 2v lambda upon c cos theta into c dt upon 2r cos theta. Here cos theta the cancel, c is the cancel, remaining d lambda is equals to v lambda dt upon r. Then this equation can be written as d lambda upon lambda is equals to v dt upon r. This equation can be written as this: d lambda upon lambda v dt upon r, v dt upon r. Now d lambda upon lambda is equals to v dt upon r. Okay, now but velocity is equals to v equals to dr upon dt. That means r is the radius. Radius means distance. Rate of change of distance is called velocity. So in the place of v we substitute this equation. So d lambda upon lambda is equals to dr upon dt into dt upon r. Here dt is the cancel, remaining d lambda upon lambda is equals to dr upon r. Purely integrating terms. So integrating on both sides, we get log lambda is equals to log r plus log c constant. So then this equation can be written as log lambda minus log r is equals to log c. Then this equation can be written as log of lambda upon r is equals to log c. This equation can be written as log c means here constant. C means not velocity. Here c is the constant. So lambda upon r is equals to constant. Lambda upon r is the constant. Then this equation can be written as here r is equals to lambda upon constant. Now in the previous session we know that what is that is t 4 upon 3 pi to the power of 1 upon 3 r is equals to constant. So then now compare these two equations. In the place of r we substitute this equation t 4 upon 3 pi 1 upon 3. In the place of r lambda upon constant is equals to constant. Okay, this equation can be written as here t, this is the t, so this is the constant. 4 upon 3 is the constant, pi is also constant, 22 this is the constant, 22 upon 7. Okay, this is also constant. So this constant, so this equation can be written as t lambda is equals to constant into constant upon 4 by 3 pi 1 to the power of 3. So this is the constant, this is the constant, totally this is the constant. So this equation can be written as t lambda is constant. So that means the product of temperature, absolute temperature, and wavelength corresponding maximum energy is the constant. So lambda into t is constant. This is the Wien's displacement law. This is the Wien's displacement law.